Who's that?
He says his name's Clive and that he's Harry's cousin.
Oh.
He said grrr.
Oh. Doesn't look very happy.
He doesn't, does he? He looks pretty angry, in fact.
Oh,
A bit shaky.
Ah.
If you're wondering about Harry, by the way, he's on a short vacation.
Oh, he's fine. Just back by about chapter 5.
About chapter 5, he reckoned. I think it's time to say goodbye to him, though. Goodbye, Clive. Bye for now, at least. He might come back.
He might come back. So, transformations.
Yes, most of this chapter is in fact revision of your Core 2 transformations.
Yeah, just go, do you remember anything? Yes.
All of the stretching, all of the reflection, all of the translations.
Even got the same table.
Yes, in fact, we'll give you a second just to refresh your memory. That way?
Yeah.
Well, then
and did one that way, and that should be enough time.
that should have been enough time,
Yeah.
saw it. And that's all revision.
Yeah.
But there is a slight advancement now.
Yes. Turns out, it matters what order you're doing.
Yes, because now, rather than just doing things for the hell of it, we're doing 2 or more transformations.
To one graph.
And it matters.
Yeah.
Not always.
But sometimes. So, you need to be ready for when it does.
Yes.
Yeah.
And we've got an example of when it does matter, and so you can see.
So you're going to do that?
Now, if you're told that, say, y equals x, you know, it's just a straight line. That's one of the familiar graphs you should be familiar with.
Yep.
And let's say it's translated and it's stretched. Does it matter if it's stretched then translated, or translated then stretched?
Well, I might have been inclined to say no.
Might have been, but in fact, it does. If you imagine you're wanting to get to... What graph do you reckon we should get to?
That's a good question. I don't know.
If we stretch it scale factor 3 in the y direction, stretch scale factor 3 in the y direction.
Sure. And already. Lazy maths.
Lazy maths. And we translate it, let's say, 0, 2.
Okay.
First we'll do the stretch, then the translation. Then we'll do the translation, then the stretch, and see how different the finished products
So
are.
you do it in different colours. So
Yeah.
you do blue.
Okay.
So we draw the original graph in the middle in black
hmm
and walk away from it. Yeah.
So it should be one of the familiar graphs, straight line. And in fact this line is important. Before we go on to any of this business, inverse functions. We spoke about them in chapter 1, but now let's do with transformations. It actually matters.
Yeah.
Kicked a little box of pens there.
I did, and a very small. There's a head in there.
There's a head.
Yeah.
Oh, it's Wilford, don't worry.
That's fine. It's fine.
So if we have a graph, say that one, it's something like that.
Yeah.
And you do the inverse function, and you want to draw the inverse function without doing all the maths we did in chapter 1.
Yeah.
What you do is you just reflect it
Over this graph.
over this y equals x line, so the reflected version would be that. So I just thought I'd mention that now while we're on transformations.
Yeah, that's something we didn't mention. We discovered might be handy.
Yeah. So I'll just
So that's
rub
that.
these off. They're unimportant to this particular area.
But while it's there, there you are.
Now you know. So we've got this.
We have. Okay. So do you want to stretch first, and I'll move it first.
Okay. Yeah. So stretch scale factor 3 in the y direction does what you think. It's the x direction that does the third.
Yeah.
Y direction does 3. So you replace the x with a 3. So it's 3x like that. Then a translation in the y direction is again what you think it is. It's not negative. It will be 3x. Then it's plus 2. That's if you do the stretch, then the translation. So that's got a gradient of 3. Go through 2. So it's about there, sort of steep.
Yeah, it's
little-
all very steep.
My blue is running out.
My blue is running out. Well, I think my blue's. Oh, there it is. It's not gone forever.
So that one will look something like that, and we'll go through to there.
Yeah.
Well, 0 to 2, but you know, y2.
But if you move it first, so you have your y equals x thing. You move it so it's outside the bracket again.
you'd have y equals x plus 2. But then when you stretch it in the y direction, that would then be in brackets and would all be times by 3.
Ooh. So that would then make it y equals 3x
Plus 6.
plus 6.
So it has the same gradient, but it would go in up here. So if Triv wants to draw that in, you can see the difference between the blue and the red line. It's just as steep, so it would be parallel, but would be off, so it wouldn't be very many marks. So if it did give you this and say it was stretched then translated,
You need to stretch it, then translate it.
or translate it then stretch it if it tells you to.
Yeah, it doesn't always matter.
No, in fact most examples don't matter at all, but as you can see some of them do, and with certain numbers it will matter quite a lot and they'll look very different, especially with quadratics and cubics.
Yeah.
And that's really the only thing that's new in transformations.
Pretty much, yeah. We looked at the other things and everything just looked like a refresher.
Yeah.
And have any other questions, obviously, send them to us, we'll do them. But
Yes.
otherwise, I think we should get on to a question.
I think we should. Let's go.
Alright. Question time.
Except there wasn't an exam past paper in the test yourself.
There wasn't, so we went for the hardest question we could find.
Which was an asterisk question, asterisk 11
Of Doom.
Page 50, if you have our book.
Yep, from the book over there.
So I'll read it to you. This question is designed to be particularly
Yeah,
hard as it can get for the exam syllabus. So have a go.
Yeah. Alright, I'll write down the important things. You tell me the important things.
I will.
Okay.
So 11a, there's 3 parts. There's an A, B and C.
Okay.
The graph of x squared plus y squared equals 1 is transformed, and it's transformed 3 times, which is as tricky as it's going to get. It says is transformed by a stretch of factor 3 in the x direction. Scale factor 3x, followed by a stretch of factor 1.5 or 3/2 in the y direction, followed by a translation of -1, 2. And then it says show that the equation of the transformed graph is x squared plus 4y squared plus 2x minus 16y plus 8 equals 0. Okay, we're going to write that down because that's what we're going to get to, because we're boss at maths.
Hopefully.
Should be. So, it's given you the order that it happened. It was that, then it was that, then it was that.
We don't know if it makes a difference at this one in particular, so we'll play safe.
Yes, you can probably assume if you get this question in the exam, it does matter.
Yeah, I think it's safe to do that. As we're getting to an equation, I wouldn't draw anything yet.
No.
This is just
We have no idea what it will look like anyway. We know what this one might look like, but we don't know what the final product will look like.
Yeah, so leave that to the end.
Leave that to the end.
Okay, so start with that.
It's stretched in the x direction and then stretched in the y. And as a general rule of thumb, you do one, then the next, then the next. But because this is x and this is y, they're independent. So
Yeah,
you can
they
actually
make
do
a
them at the same
difference.
time.
Yeah. So, let's do that.
Okay, so stretch scale factor 3 in the x direction. The x direction is the weird one.
It is the one where it's on the same side as the equal sign, and it becomes a third.
Yes, so when you put it in front of an x, it's not what you think.
No, it becomes a third x squared, but the third x is in brackets.
That's right, the x is actually replaced directly with a third x.
Yeah.
So then whatever happens to it happens to the third.
Yep, and then we do a similar thing for the y. I feel like the equals thing is quite important.
Yes, if all of this stuff was on this side, and it said it's been stretched scale factor that in the y direction, you'd normally put that actually in front of the x. Not
Yeah.
like this, it would be in front of the bracket if you remember your transformation rules.
Yeah.
But this time it's going to be in front of the y,
Because it's the
so
same
you
size.
actually flip it, so it's actually almost as awkward as the x one in this particular case.
Yeah, so it becomes 2 over 3.
And again, it all becomes one item.
Yeah.
It's like that, and it's all squared. I'm going to bring the 1 over now,
Okay.
-1, and it equals 0.
I'm sure
It does now.
it does now. It's actually 1 in the end, so yeah.
Expand these out before you do the translation.
I would, I think it'd be really confusing. So, squared 9th x squared,
Plus 4/9 y squared.
and minus 9.
-1 at the minute equals
Oh,
0.
I'm a step ahead.
You are a step ahead, and I think the step you did makes sense before we do the translation, is to get rid of the fractions.
Yes,
And to
because
do
they're
that,
not very
you times
friendly.
by 9. So that times by 9 is just going to be x squared.
And that's going to be 4 y squared And then it's going to be -9. Sorry.
Then you want to do the translation, because we've done these two, and it's followed by that.
Yep.
So,
let's do that. So when it's in brackets, it's the opposite way to what you think.
yes, so rather than being -1, it's plus for the x. And again, that's all in brackets, then it's squared, because the x is directly replaced.
Yes.
Plus 4 lots of y minus 2 squared minus 9 equals 0. Now I'm going to expand all of these brackets because that is not the answer we're wanting to get to.
No, it had 16s and stuff in it.
Triv, you may need to check my math.
Okay, so x squared plus 2x plus 2 is what I'd get.
I've got plus 1.
1. Oh, yep. 1 times 1 is not 2.
Plus 4y squared minus 16y plus 16
Yeah.
minus 9 equals 0. Then I'm going to put it in descending powers and simplify it out. So you've got x squared plus 4y squared plus 2x minus 16y. Oh, that, and that is just plus 8. And that equals 0. Before we move on, I think I better check.
Yeah, is that the same? Fingers crossed.
We are showing that it's x squared plus 4y squared plus 2x minus 16y plus 8.
Yep.
Any
Equals 0.
order matters. Any order doesn't matter.
Yeah.
B, now you sketch it.
Right. So, what does that look like? Well, when it was there, it reminded me of a circle.
Yes. Except slightly sneaky. It's got a 4 in front of the y. That would actually slightly stretch it in the y direction, so it would be more like an oval.
In the x direction.
In the x direction, sorry. Yeah, that's what I mean.
Yeah.
So that's what it will look like. But we can do the centre points like normal. We can work out somewhat of a radius. And then we can draw it and we can find the points where it crosses the axis.
So that you should draw an axis. It's a good place to start.
It's a very good place to start. The
Okay.
centre, just like from circles back in core 1, is minus 1
So put that there.
and then plus 2.
Yeah, the
2.
4 doesn't make a difference here.
4 doesn't make a difference. If it was inside the bracket, you'd divide the 2 by 4 and you'd get half. It's outside the bracket, it's still 2 up.
So that's our centre point.
That is our centre point.
Okay, now, I think a place to go is where will it cross the axes?
Yes, that is a good start. So it crosses here when x is 0.
Yep.
So if you just get
vice
rid of these
versa.
x's and you're left with y,
So if you do that.
yep, you're going to have 4y squared minus 16y plus 8
Yep.
equals 0. That can be simplified to y squared minus 4y plus 2 equals 0. That can't be simplified, I'm going to have to use the quadratic formula.
Yeah.
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 4 plus or
Would you like a new
minus.
blue
I would
pen?
like a new blue pen. I did this.
That blue pen is pants. I think you've still got it, haven't you?
Apologies.
There you go.
So 4 plus or minus the square root of 16 minus 4 times a times c minus 8 over 2a, which is just 2. So you've got 4 plus root 8 over 2 and 4 minus root 8 over 2.
That's not very nice. What's root 8 similar to? Root 9, bit
Yeah.
less than.
It's a bit less than 3.
Okay, so 4 plus 3
About 7 divided by
by
2.
2,
About 3.5.
about 3.5. So if I put a mark where a 3 is, it's going to cross there.
It's going to be about there-ish.
Okay,
And then 4 minus about 3 divided by 2, going to be between 1 and a half somewhere.
so if I put a mark at
Out there somewhere.
yeah.
So these are the
1
2
and a
points it
half.
crosses here. We can do the same thing if y equals 0. You end up with x squared plus 2x plus 8
Okay,
equals 0. That has no real roots. So it does not cross the x-axis. And we know it's going to be slightly oval shaped. You can determine it will probably look something like that.
yeah.
Where that's the centre. I've drawn it pretty poorly there. But that is the centre and it's somewhat oval.
Yeah, we can
Go
work it
for
out
those 2
because
points.
of the 4y. We don't actually know how ovally it is, but we can work that out.
We can work that out. But at the minute it just says sketch. We'll go on to part C and then if we want to work it out we can.
Okay.
Part C. Oh, what are the equations of its axes of symmetry?
Okay,
which is actually what we'd have to do to work out the edges anyway.
So the axis symmetry are going to be that line.
Yep, going through the
Ish.
centre, and that line going through the centre. We know what that line is because we know what that centre point is in the x direction.
Yep, that's x equals 2.
X equals 1.
1, sorry.
Y equals 2. Yeah, x equals minus 1 in fact, not 1.
Yeah.
And then y equals 2. And those are the two lines of symmetry, x equals minus 1 and y equals 2. Those are two horizontal and vertical lines.
So with that in mind, we can now work out where this line intersects with our very strange circle shaped thing.
We can, and what we do there is we make this y equal to 2.
Yeah, so we put all 2 in place of every single y in our equation.
We do.
That one.
Yeah?
Yeah.
That makes sense, doesn't it? So then you'd have
X squared plus
and then, so if that's 2, 2 squared is 4, that'd be 16.
Yeah.
Plus 2x, can't do anything with that, yeah. Minus 16y, which is actually minus 32 now.
Yep. Plus 8
equals 0.
So we
Which is
simplify that first.
x squared plus 2x
Plus
8. Plus 8 minus 8. Minus 8.
Minus 8 because it's minus 32, yeah, sorry.
Minus 8 equals 0.
And that factorises
I'm just looking. It does indeed.
to
Does it?
4 and minus 2.
Yes. So you've got x plus 4, x minus 2.
So to find the points, you then take that out of the bracket, it becomes the opposite. So x was minus 4.
And x equals 2.
So those are the points, and that looks quite believable.
It didn't actually ask for that, but in an exam it might be worth doing that if you're not 100%.
And that would
sure
confirm
marks.
that it is an oval, otherwise it wouldn't be.
Yes, right.
Yeah.
As you can see, either direction that way, it's got a radius of 3, but upwards it's got a little bit less than that.
Quite a bit less.
Quite a bit less than that actually, isn't it?
A bit less than 1. So, there we are.
And that was tricky. Firstly, because it has 3 transformations. Secondly, quite a bit of maths. And it's a blooming oval.
We've never seen the oval before. What's that about?
It's maths for you though, isn't it?
Yeah, it's
It's
a
a
more
hard
exciting
question,
involvement.
and we've done it. So, well done us. Hopefully well done you.
Yeah. Now onto the summary.
Yep, let's do it.
So, I realised after saying summary time, it's a really short video.
Yes, it is. There isn't much to say. It's mostly revision from Core 2.
Yeah.
But a little bit of advancement, so we might as well summarise anyway. Sometimes it matters the order you do transformations when you do more than one.
Yeah, and sometimes you get ovals.
That was a horrible question, that aspect.
It was. And at one point, we just skip over a little bit.
Ah, yes. When I said this doesn't work, I'd quickly done the discriminant in my head.
Yeah, so you
I
can
should have
work out.
said, and don't think I did.
No, I noticed afterwards that they probably didn't. We do quite a lot of maths in the same room and talk to each other about it, so we both knew we were going to do discriminant. But you're not in our inner circle yet. If you go to our video, you'll be in it. But
Oh yeah, if you look at Meet the Writers, you'll be in our inner circle.
But until then, it might be a bit confusing.
Yes, so yeah, I did the discriminant there. And if there's any bit of any video, from AS or A2 or GCSE or anything,
Yeah, if any extra questions, they go, what do you actually do at that bit? Or why does that bit happen?
we do tend to rush the videos a little bit in terms of arithmetic.
Yeah,
so
'cause
if
it's
we
because
miss
of
out
division.
telling you what we actually did, please let us know if you don't understand still after watching our video. That's what the
Or any
service
questions
is for.
anywhere. And then we'll do a special video just for you. And I've lots of people ask the same question, but put it on YouTube.
Yes. And we realise we have the old AQA book. If you have a newer one, or even a different older one, or whatever you have,
We'll still be able to do questions.
and if it's a different course, whether it be EdXL or OCR maths,
We'll give it a go.
We'll give it a go.
Yeah.
So, there you go, that lengthened the video slightly.
There you are. More of a summary now.
Yeah. But, yes, that's the only thing that's new. Sometimes the order you do it in matters, and it can throw you off if you're not careful.
Yeah, just remember your rules from the table and you'll be alright.
I would get that table printed firmly in your mind
Just
as
practice
soon as
it.
you can.
Yeah.
And that's chapter 3
Ta-da!
of Core 3.
Yeah.
We've only got chapter 4, and then Harry's back.
Yeah! Okay, I'll be able to get on that then.
We'll see you at chapter 4.
Let's do it.